marking question 9 here. You can see that I've written a load of stuff in blue and black over that table there just to try and work these questions out. But we got data in the table for vanadium half equations and then chlorine, iron and zinc half equations too. So basically, first one, use the data to identify the species that can be used to reduce VO2 1+ ions to VO2+ ions in aqueous solution and no further. So our answer here, our reagent is Fe2+. I made my explanation as I was doing the question. And it is this. Fe2+ has an E0 value that's less positive than the E0 value for VO2 1+, but more positive than the E0 value for VO2+, which is basically what that says. Okay, so it sits in between the two. So it's going to reduce one, but it's not going to reduce the other. Now, there's quite a bit written in this additional comments. Accept any Fe2 compound, correct formula or name. So if you wrote, for whatever reason, FeCO3, then you get the mark. Or if you wrote iron 2+ in words, then you still get the mark. If calculations of EMF are provided, producing EMFs as 0.23 and minus 0.43 with a comment, allow M2. So essentially what they're saying is if you actually worked out the overall EMFs for those cells and said, well, that one actually is feasible because it's positive and that one's not feasible because it's negative, then yeah, there you would get the mark. And then allow E0 value of Fe3+ is between the E0 values of electrode half equations. Okay, so that's me saying it in words, so it's more akin to what I've said. I didn't mention plus 0.77, but yeah, that's what I've put in words, so that's fine. That's 2 marks. I'm not going to spend any more time on that. Oxidation state of vanadium in that compound is +4, so you can have +4. You can have in Roman numerals like I did, or 4, so that's cool. Draw the structure of the other isomer of this vanadium complex now and state the type of isomerism. So what we've got here, and if I can just zoom in on this on the right, you can see how these chlorines are now opposite each other, and I've done that. Okay, even though they're in a different position, but they're still opposite each other, just looking at it in a slightly different way. So that's fine. Ignore absence of charge. Wedges, dotted lines and square brackets are not required. Do not penalise bond from H to V in water ligands. Oh, that's a bit naughty. You should be going, you know, in terms of those bonds between the vanadium and oxygen, they should be going to the oxygen, not to the hydrogen. But apparently they're letting you get away with that here. Type of isomerism is cis-trans. Allow EZ, geometrical, and oh, they do accept stereoisomerism. I was saying during the question that I didn't think they'd accept that because it's just a bit vague. Of course, cis-trans, EZ, geometrical is a type of stereoisomerism along with optical. So that's why I thought stereoisomerism would be a bit vague, but apparently they're accepting it, which is good news for you guys, I suppose. Okay, just a bit more leeway. Heating NH4VO3 produces vanadium 5 oxide, water and one other product. Give the equation. Well, this is going to be right or wrong, isn't it? 2NH4VO3, V2O5, H2O, 2NH3. That's my one other product, 2NH3. And during the me doing the question, I actually showed you how I ended up doing that. Now this last one, I think it's one of those you just need to know because I've seen it come up lots of times. And how does vanadium act as a catalyst in 2 equations? So it reacts with the SO2 to give SO3 by donating an oxygen atom, but then it's regenerated by accepting an oxygen atom from just pure oxygen. So that's 1 mark there. I don't know why I've done 2 ticks, but that's 7 out of 7. So yeah, a little bit of a tricky electrochemistry question. I suppose earlier in the paper there was like an electrochemistry question based on 2 copper half cells, and I didn't think it was very big, so that's probably why they've stuck a little bit more in another question further down the line with respect to vanadium, and then they've asked some other stuff with related to vanadium as well. So yeah, nothing too scary there, I think, but you know what, it's the it's this bit is probably the most difficult, and how you word it, that's always the way, isn't it?
Make sure you subscribe to our channel so you can keep up to date with all our new content. If you like this, you'll love our free trial. Click the link and check it out. You've now got two choices. You can wait and see what YouTube randomly throws up, or you can improve your grade in under an hour by checking out my awesome chemistry transformation playlists.